Now I'd like to do a quick demonstration of an exercise that you can do to analyze a soil sample on your own. So here I am on the hill in my backyard, and I'm just going to collect a small sample for our analysis. Now for today's experiment, I am going to avoid the surface horizon, because if you look at the surface, you can see it's heavily rooted, which makes it very difficult to analyze your sample. So I'm just going to, for the sake of the demonstration today, I'm just going to dig off all that top layer that is rich in organic matter, and I'm going to get down to the subsoil to get a sample that we can analyze. So I'm deep enough now that I can dig into the side, and I now have a nice soil sample that has very little roots and organic matter in it, so it's much easier for me to work with. To measure the amount of sand, silt, and clay within a soil sample, you just need a few simple pieces of equipment. One thing you need is a large mason jar. Any approximately quart-size container that you can seal, that's clear and has a flat bottom will work, but a mason jar works really well. You need some water, just plain old tap water, a marker, a ruler, and a calculator, and of course the soil sample. And to prepare your soil sample, you simply just need to take it with your hands and break down the big chunks into small pieces, and then remove anything like twigs, sticks, rocks, anything like that that isn't actually soil. I've already added my soil sample to the mason jar. You don't need a set amount. You just want to get the jar anywhere between about a quarter to a half full. In this case, I have it right about a third full, and that works out really well. Next thing I'm going to do is I'm going to take water, and I'm just going to fill the jar, and I want to fill it about 80% full. That way there's still plenty of room that I can, once I cap the jar, I'll be able to shake the soil water mixture. So I put the lid on. I'm just going to take my sample and I'm going to shake it really vigorously for several minutes. So you just want to shake it up to get the soil sample completely saturated, and shaking it breaks down those large pieces that we call aggregates down into the individual particles. And so you need to shake for about 3 or 4 minutes to get everything again well saturated and get those particles to break down. Once you've shaken it for several minutes, you're just going to take your jar and you're going to set it in a nice quiet place that's out of the way so they can sit there for at least 12 hours without being disturbed. If you need to wait until the next day to finish up this experiment, 24 hours or more of sitting is perfectly fine. And so what's happening as the soil is sitting there, the particle sizes are going to settle out naturally into their size classes. Sand is the largest, and so it's going to fall out first and form the bottom layer. Overlying that will be silt, and then clay is the finest size, and so it will settle out the slowest, and it will form the top unit. After at least 12 hours has elapsed, you can take a marker, and on your jar, you're simply going to place a boundary in between, place a line marking the boundary in between the individual units. So I've got a line marking my boundary between sand and silt, the boundary between silt and clay, and then I also have a line marking the top, which is clay. So this is my sample after 24 hours, and you can see the boundaries I've already marked on here. So to determine the percent size class of each unit, then, I'm simply going to take my ruler and I'm going to measure the thickness of each unit. I like to work in the metric system, but if you want to use inches, that's fine. But on here, if I measure these, the sand unit, which is the bottom, measures 30 millimeters thick. The silt, which is the middle unit, is 9 millimeters thick. And the clay, which is the surface, is 14 millimeters thick. If you add the thickness of the 3 units up, that is a total of 53 millimeters. And to get the percent of each class, then, is you take the thickness of that unit divided by the total thickness. Or in this case, 30 divided by 53, 9 divided by 53, and 14 divided by 53. If you do those calculations, you end up with 57% sand, 17% silt, and 26% clay. And now you can take those values and plot it on the USDA textural triangle, which is a graph. You can just do an internet search for USDA textural triangle. You'll get that graph, and you plot those 3 values And in this case, my sample with 57% sand, 17% silt, 26% clay, that is classified as a sandy clay loam. So you can do this experiment on your own, and you can alter the experiment a little bit, try different samples, have your samples sit there for different lengths of time, shake it longer, see if your results end up any differently. Thank you.